Welcome back to the ARM Viewpoints podcast. I'm really excited for today's episode, which we're calling Raspberry Pi, Empowering Millions to Innovate. I have to confess that I'm a longtime fan of the Raspberry Pi, so I'm delighted that our guest today is Eben Upton, founder of the Raspberry Pi Foundation. Welcome, Eben.
Great to be here.
So, for those who don't know, the Raspberry Pi is a small form factor computer that's used for both educational purposes to learn programming and larger professional projects. And since the company was founded 10 years ago, it's grown from strength to strength. So maybe we can start by giving listeners a bit of background about Raspberry Pi and the company's journey over the last decade.
We had a problem, I guess, in Cambridge 15 or 20 years ago, which was that nobody wanted to come here anymore to study computer science. It is one of the best universities in the world to study this stuff. And it's the University of Alan Turing, obviously. It's the University of Maurice Wilks, briefly the University of Charles Babbage, but the University of Maurice Wilks. So I'm in the Maurice Wilks building now, which is where Raspberry Pi is based. And Maurice, who I very fortunately got to meet when I was an undergraduate at Cambridge, ran a program called EDSAC, which generated the first, really, certainly the first real proper scale programmable computer in the UK and one of the very first in the world back at the tail end of the 1940s. So this is a great place to study computer science. And we found ourselves unable to persuade very many people. We were down to about 200 applicants. By 2008, we were down to about 200 applicants, down from a peak of 600 10 years before. Down to only 200 young people a year expressing interest in coming here to study computer science. And we kind of asked ourselves, a group of us at the university asked ourselves, what had happened? The idea we came up with was, we had back in the 1980s, we had programmable computers. So young people like me had access to machines like the BBC Micro that we could learn to program on. And then it was natural for us to go to university and study computer science. Those machines went away. The students went away. Quite simply, Raspberry Pi is a test of the hypothesis that if we bring back the machines, if we bring back the cool tech, then maybe young people will become interested in computer science again. That's really all we were trying to do, solve this very simple little problem for the university here in Cambridge.
As you've been solving that problem, and in the last 10 years, as you've developed the Raspberry Pi through a lot of different generations, there's so many exciting and creative projects that leverage the Raspberry Pi. In fact, I recently read an article about a guitar pedal that used machine learning for effects, which was fascinating. So which ones have you found the most interesting over the years?
I've always found the space-related or space-adjacent Raspberry Pi applications a lot of fun. A big culture of high altitude ballooning with Raspberry Pi, putting Raspberry Pis under a weather balloon, get up to about 40 kilometers, and then taking pictures. And you can see the curve of the Earth, the blackness of space. It's fun as a geek, but it's also fun from an educational perspective because it really dramatizes to kids exactly how close space is. So really enjoy that one. We have our own space-related program as well, of course, called Astro Pi, where we have a couple of Raspberry Pi, first-generation Raspberry Pi, so fairly antique hardware now, on the International Space Station. About 15,000 groups of school children now have run their code in space on a Raspberry Pi, which is kind of fun.
You've clearly harnessed the desire for a lot of people to make exciting projects, and it's created an enormous developer and maker community working with Raspberry Pi. So maybe you can tell us a bit more about your involvement with them and why you think Raspberry Pi has been so successful and popular.
I think Raspberry Pi it's what we call a category-defining product, in that it's a product that you couldn't have focus grouped into existence. It's hard to ask somebody, do you want this thing before it exists? But it turns out there was latent demand. So just as with tablets, people actually turned out we did want tablets, but the only way to find that out was to go make them and discover they were incredibly popular. People had a latent desire. Lots of people had a latent desire, particularly in the hobbyist community, had a latent desire for something which occupies this role of glue, occupies this role between the physical world and the computing world and the networked world. And then we put it in the market, and it just tapped into this latent demand. Unfortunately, of course, we were able to, because of the way our business model works, of course, a very similar business model to ARM. We're primarily a licensing company. Because of the way our business model worked, we were able to scale the business very quickly into this demand. We went from nothing to 100,000 orders on the first day to 1 million units shipped in the first year. So it was a very hard takeoff, and we were able to kind of keep up with and nurture that demand all the way through. And where that demand initially came from the hobbyist sector, over time, what we've seen is those hobbyists are the people who have taken Raspberry Pi into their workplace. A lot of our industrial designs come from individual hobbyist engineers bringing the thing they love into the workplace. They're also the people who took it into education. So our kind of attack on our interface to education, the educational world, has been a two-step process of engaging enthusiastic teachers, enthusiastic volunteers, and then those teachers and those volunteers then going and engaging the children.
So that kind of leads me to my next question, and it's around the ARM Cortex M0 Plus processors and your use of them. So what was the team's experience of designing Raspberry Pi's first silicon device in-house? And what led the team to develop an MCU and to select the Cortex M0 Plus?
Prior to Raspberry Pi Pico, which is the product that launched in January of this year, all Raspberry Pis have been basically the same. There's enormous difference in performance between a Raspberry Pi 1 and a Raspberry Pi 4. It's about a 40-fold increase in performance. But they are fundamentally the same thing. They're fundamentally Linux computers. What they aren't is microcontroller platforms. And of course, they come with that distinction comes with lots of advantages. We have lots of interfacing opportunities, USB 3, gigabit Ethernet, dual band Wi-Fi, enormous amounts of memory, gigabytes of memory, gigahertz of processor, right? But there are things you can't do. So it's not a platform which is well suited to very fine deterministic control of I/O in the way that microcontroller platforms are. It's not a platform that will scale down in terms of power consumption in the same way that microcontroller-based platforms will. And there was never really a way to build a device which was recognizably a Raspberry Pi, but was also a microcontroller platform. So the team, I think, were, as I understand it, there was a sort of a process of going out and looking at what was available in the market, a dissatisfaction with what was available in the kind of merchant microcontroller market, and then a determination to build something in-house. What that led to was, a selection. It's a core selection, which is effectively based on efficiency. What's good about Cortex M0 Plus? It's a small core. It's a power-efficient core. If what you want is lots of integer performance, it's a great core. It's a great core for that. It has a feature called SIO. It has a single-cycle I/O bus that lets you connect to and supervise external pieces of hardware elsewhere in the SoC. Lets you control those with very low latency. So it's kind of a good choice for a chip that was focusing on flexible I/O. Flexible I/O really is one of the key selling points of this device.
Yeah, it looks like it has. Were there any other key architecture decisions behind this choice that you wanted to highlight?
Let's have a think about what we think is good about this chip. It has a substantial amount of integer performance because it's implemented on a modern process node. It's been possible to take those Cortex M0 Plus cores and implement them at a relatively high frequency. So they come out of the box running at 133 megahertz. Chip's got an enormous amount of overclocking headroom actually over that point. But even at 133 megahertz with two cores, you're getting a lot of integer throughput. It has a lot of memory on there. So certainly for an M0 Plus based design, it has over 1/4 megabyte of single cycle SRAM on the chip. That's extremely useful in terms of, programmer productivity. Obviously you can do more with it that has more memory on, but why do I find more memory exciting? I find it exciting because it means programmers can focus on implementing features rather than trying to squeeze their code down into 8 or 16 or 32K of RAM. I guess the last thing is I/O. So it has the usual collection of low-speed serial interfaces, UARTs, SPIs, I2Cs, but it also has a thing called PIO, which is a programmable I/O subsystem, which really automates the process that's often called bit banging, the process of taking a wire protocol that doesn't have native support in the chip, where there's no native controller for that protocol. The example people often give is NeoPixels, these little LEDs that you can put on a ribbon that have a little piece of logic inside them that makes them addressable. Very few microcontrollers have a peripheral that can control that, but PIO lets you build a very efficient software-based peripheral that can control those LEDs. And what we found with PIO is it's been incredibly flexible. You can use the same piece of silicon to drive a DPI display, a DVI display, read an SD card, drive some of these LEDs, drive an I2S audio codec. All of these things can be bit banged with PIO. So it's that combination of high integer performance, lots of memory, and very, very flexible I/O.
What sort of projects do you see this being used for in compared to other Raspberry Pi products?
I think it will be used. I think it is being used in combination with the big Raspberry Pi products in a lot of applications, because you often need both a lot of computing capability and ability to access the network and high-speed peripherals, along with deterministic control of the real world. world. So I think in a lot of cases it's part of a pairing of the two tiers of product. On its own, really, I think one of the big places it shines is power consumption. It isn't the lowest power microcontroller in the world, but compared to a big Raspberry Pi platform, it is extremely low power consumption. And so for kind of battery-powered operation, where you would need days of operation out of a battery, it certainly shines in that area.
So will Raspberry Pi be designing more silicon chips in the future? And if so, what areas do you see it addressing?
Obviously, there is silicon design capability at Raspberry Pi, and it would be a shame not to use it. Right now, though, I think we are very focused on this one design. There is a lot of work to do, as a lot of work for the team to do in bringing this design to scale. Right, we have it's been in the market for 4 or 5 months. It's sold hundreds of thousands of units. We of the Pico product, so we're kind of unusual in that the organization is both making silicon and then making a product which uses that silicon. So there's a lot of effort actually at the moment on production engineering. And they're the same people who do the production engineering. So, obviously, I'm sure we'll come back to this in a few years' time. I would think, maybe different core choices, different I/O choices, conceivably, different packaging choices. I mean, there's all the usual dimensions. I think you can go and look at the world of microcontrollers and you can say, well, we're in one corner of that world. Which bits of it could we go and address with some subsequent product? But yeah, for now, I think we've probably got we frequently find ourselves maybe on a 3-year cadence where you probably have a year of learning, a year of thinking about what to do next, a year of sort of thinking about what changes you'll make in response to those lessons, and then a year of implementation and a launch. So I think we're probably about 3 years away. We're a year away from having any idea of what we want to do. We're probably 3 years or 2.5 to 3 years away from actually doing it.
Well, that's a great sketch of kind of the medium to long term. I wanted to switch now and talk a bit about kind of how you get there and what the journey is like, particularly in working with ARM. I know that you joined the ARM's Flexible Access Program to help design your own custom systems on a chip. Maybe you can tell us a bit about that experience, some of the challenges, what you see the benefits being, and how it's all worked.
One of the problems with traditional IP procurement for silicon is you have to know what you want before you get it. And that's fine a lot of the time. If you want a PCI Express controller, you want a PCI Express controller, you can go to the companies that make PCI Express controllers and say, give me a PCI Express controller, give me a quote for a PCI Express controller. You can get a bunch of quotes and then you can procure some IP. The challenge in a space certainly like processors is there's quite a broad spectrum of IP that you could choose, even within one vendor like ARM. And it can be a little bit hard to know which thing you want until you've got it. And that's pretty inefficient and I guess promotes all sorts of suboptimal behaviors. What was very attractive about ARM Flexible Access was that it gives you both access to a very broad menu of IP, a really surprisingly broad menu of IP. I mean, there's an awful lot of stuff on the menu in AFA. And so it gives you this very broad menu. It gives you predictable pricing. So it's not a case of, you know what something is going to, before you engage with a particular piece of IP, you know what it would cost you if you decided to take that all the way through to production. So those two are actually very, very, very attractive things. And it lets you play around and experiment. That was very helpful. Contractual complexity is obviously very simple as well. There isn't really a contractual negotiation process. There's just the AFA license, and it's a very easy to sign piece of paper. And really, it does take a lot of the friction out. I think that's the thing. All of these things I'm describing are friction. Either real friction or there's a kind of this fear of missing out, which imposes a psychological friction on you. And so having access to all but the very highest end elements of the ARM IP offering has been very helpful.
I was going to ask you if you could pick one thing that this flexible access initiative has enabled Raspberry Pi to do, what would it be? And I mean, it sounds like flexibility is part of it. Do you have other aspects that you'd wanted to highlight?
I would say pick the right core. And that's an instance of flexibility. It lets you pick the right core. And I think I think the core choice in RP 2040 is the right core. And it's easy to make that right choice in the context of flexible access.
Maybe we can talk more broadly about the ecosystem and what synergies you see between ARM and Raspberry Pi for supporting and growing that ecosystem.
I think ARM and Raspberry Pi have very similar goals in a lot of ways. We both have an interest in the engineers of the future. ARM has run a very impressive education program for a very long time. And so we kind of both have an interest, probably a complementary interest, where ARM's educational efforts are often focused at the tertiary level. They focused at the university level, where we're really focused as an organization, certainly as a charity, on getting people to the tertiary level, right? We're focused on getting people through school and nurturing some enthusiasm for computing during that part of their lives. So that's the thing. On the sort of kind of commercial side, I mean, I grew up with a BBC Micro, and I grew up thinking about wanting an Acorn Archimedes, which of course was the very first machine that had ARM in it. And then I think we went through a period where PC was synonymous with another instruction set architecture, and that was very sad for me. And so there's a great deal of satisfaction for me in being one of the world's largest PC companies, but we're certainly one of the world's largest ARM-based PC companies, and sort of bringing the ARM architecture, which has been enormously successful in embedded and mobile applications and is increasingly successful in the PC space. Being part of bringing this architecture back, really, because that's where it started, bringing this architecture back into the PC space, certainly personally very satisfying for me.
As you say, it does kind of harken back to where we kind of started, that there was this excitement and energy and enthusiasm that you've helped nurture and inspire in people. And I wonder where that takes us over the next 5 years, and particularly what's next for Raspberry Pi over the next 5 years. I know we talked a little bit about that earlier, but maybe you could kind of cast your mind out over a 5-year span and tell me what you see.
That's an interesting question. I think you can break it down into, I guess, the products and the mission. In terms of the products, still kind of we're coming up actually on the second anniversary of Raspberry Pi 4, and Raspberry Pi 4 was a transformational product for us because it's the first really genuinely PC class Raspberry Pi. It's also interestingly a product that came along at a very relevant time for the pandemic. We've done an enormous amount of work over the last year in deploying Raspberry Pi based PCs to young people, primarily in the UK, but also some in the US who have needed hardware in order to be able to learn from home. But we're still, in my mind, early in the life of Pi 4. I think it's because it was such a revolutionary uplift in performance for us. It's still a platform that has a lot of legs. It has a lot of optimization yet to do. We can eke more performance out of it in software. We may be able to eke more performance out of it in other ways as well. So you're probably going to see for most of that 5 years, actually, us being very focused still on Raspberry Pi 4, but probably more on the software side than the hardware side. That's the platform, Raspberry Pi, the platform. In terms of the mission, I think we've been very successful at reversing this decline that I talked about in the number of people interested in computing. Certainly at Cambridge, we went, as I said, from 600 in 1999 to 200. This is the number of applicants for about 100 places. 600 to 200 to 1,400 last year. So computer science has gone from being one of the easiest courses to get into at Cambridge to almost the hardest course. Uplift in interest. Uplift in interest is not entirely due to Raspberry Pi, but we've been an important participant in the ecosystem that has driven that increase in interest. So I think and that's been mirrored across the rest of the higher education system in the UK. I think the opportunity really in terms of mission is to recapitulate that effort in the context of other developed world countries and in the context of other developing countries as well. Obviously, computing is both at the individual level, computing education is at the individual level. A really powerful driver of economic mobility. Teaching young people to do STEM subjects. STEM subjects are hard. We talk about this thing where you say, success in STEM subjects is to some extent, it's a very objective thing, right? A computer program doesn't care who your dad is. You can't, if your dad gets you a job as a computer programmer and you suck at computer programming, you're going to be out on the street, right? So it really cares about whether you're good rather than who you know. So at an individual level, enormously, it's a fantastic. I know so many people who have come from very challenging backgrounds and have had very successful lives on the basis of having had some exposure to STEM education when they're young. So on an individual level, it's very powerful. On a societal level, it's incredibly powerful as well, because a society that trains a lot of people to do interesting STEM stuff is a society that's going to be able to compete in the modern era. It's obviously great for the UK that we've been doing that here, but obviously we want to recapitulate that everywhere else. And of course, it can be a powerful driver for lifting some lower middle income countries really up into the high income bracket. So very excited about that. Just hired our first employee in Africa. We're based out of Lagos, which is super exciting for us. So I think there are some wonderful opportunities to do good work there on the commercial and technical side, and also on the charitable side.
It seems that there's a real democratizing aspect to what you've done with Raspberry Pi. I mean, just in terms of the enthusiasm and the breadth that it generates, and also the fact that it is, very, very cost effective. And there are a few platforms that you could look to that will provide the same level of capability at the kind of price point that you're able to achieve. Just talk a little bit about that democratization and what you see the impact of that being.
It's interesting. If you go back to, there's a thing called the Whole Earth Catalog that you may have come across.
I remember it.
Indeed,
yeah.
And it's there was all about access to tools, right? So this is from the late 1960s and early 1970s in the United States. A big catalog of all the stuff you need if you want to go. Quite a big emphasis on self-sufficiency. And if you want to go and live in a Buckminster Fuller dome out in the wilderness in California somewhere, and you want to be able to purify your water you get from the stream, where do you actually, in the pre-internet world, where do you find out how to build your Buckminster Fuller home, and where do you find out how to purify water? So this idea of access to tools has always been at the heart of what we do at Raspberry Pi. There are people, it's back to, why was Raspberry Pi successful? Because there were people who wanted tools, and we made tools. So it's always been about providing people with missing tools in their lives. And of course, a big part of that's always going to be about costs. We think about being kind of the new BBC Micro, but in a lot of ways we owe a lot of debt to the Sinclair machines, the ZX81 and the Sinclair Spectrum, because while the BBC Micro was a platform that proceeded from a feature set to a price, the Sinclair machines were machines that proceeded from a price to a feature set. People ask me how you decide what to put into a Raspberry Pi, and the answer is really whatever you can fit in to $35 in any given year. And over time, the operation of Moore's Law outside our organization and the kind of accumulation of operational experience and efficiency inside the organization has driven this enormous increase in what you can do for $35. But it always still proceeds from $35 in the way that Sinclair did.
That does remind me of Sir Clive and his kind of designing to a price point and then having the ecosystem kind of fill in the gaps. I'm inspired by the work you're doing and your insights on working with ARM. Thanks so much for bringing them to us, Eben. Don't forget that ARM Dev Summit 2021 is coming to your screens October 19th through the 21st. The 3-day virtual conference is where hardware and software join forces. It will serve up insights into the latest technology trends and provide engineers, developers, and tech enthusiasts with technical sessions, hands-on workshops, and networking opportunities with like-minded software developers and hardware designers. Sign up to stay updated by visiting devsummit.arm.com. We look forward to bringing you more conversation in the next episode of ARM Viewpoints. Thanks for listening today.